We're constantly buried in data. Product reviews, survey results, you name it. And it's so easy to just grab an average score and think, okay, I get it. But that single number, it often hides the real story. So how do we peek behind that curtain and see what's actually going on? Let's dive in.
So picture this. You're looking for a place to eat tonight. You see two restaurants, and they both have a solid 4-star average rating. So they're basically the same, right? Well, maybe not. What if one place is just consistently pretty good, while the other is a total gamble? Some people think it's the best food of their lives, and others had a terrible time. The average doesn't tell you that, does it?
And that really gets to the heart of the problem with averages. The average, or what statisticians call the mean, is the tool we all reach for first, but it has this one huge weakness, a blind spot, that can lead us to some seriously wrong conclusions.
Now, we all know how the mean works. You just add everything up, divide by how many things you added, and boom, you've got your number. It's simple, it's fast, and it's a decent place to start.
For example, let's say a product has 5 customer ratings, a couple of 8s, a few 9s. You do the math, and the mean is a really nice 8.6. Looking at that, you'd feel pretty confident. Looks like almost everyone loves this thing. It's a safe bet, for sure.
But here's where the trouble starts. The mean is a total pushover when it comes to extreme values, what we call outliers. So what happens if just one of those customers had a genuinely awful time and gave the product a 1?
And whoa, look at that. Just by swapping 1 9 for a 1, our mean plummets from 8.6 all the way down to 7.0. That one single bad experience dragged the entire average down with it. Suddenly, the picture of customer satisfaction looks completely different and way more misleading. So if the mean is that easily fooled, what are our other options? Well, lucky for us, there are other ways to find the center of our data that aren't so sensitive. Let's talk about the median and the mode.
First up is the median. The median is literally just the middle number once you've lined all your data up in order. In our last example, with that one angry customer who rated it a 1, the median would still be a solid 8. It just shrugs off that extreme score, giving us a much better idea of a typical customer's experience.
And finding it is super easy. You just sort your numbers from low to high. The one sitting right there in the middle, that's your median. And if you have an even number of data points, no problem, just take the average of the 2 in the middle. Easy. Then you've got the mode. The mode is even simpler. It's just the value that pops up the most often. Now this one's really special because it's the only measure that works for things that aren't numbers. Like, you can't find the average favorite color, but you can definitely find the most popular one, and that's the mode.
So, what's the big takeaway here? It's all about picking the right tool for the situation. If your data is pretty symmetrical and doesn't have any crazy outliers, the mean is totally fine. But the second you have outliers, the median becomes your best friend. And if you want to know what's the most popular choice, especially if you're not dealing with numbers, the mode is the way to go.
Okay, so we're feeling pretty good. We've got better ways to find the center of our data. But is that it? Is knowing the center really the whole story? What if I told you 2 completely different sets of data could have the exact same center?
Yeah, to get the full picture, we have to look beyond just the center. We need to understand the spread of the data. Basically, how consistent are the numbers? Are they all clustered together, or are they scattered all over the place?
So let's look at product A. Its average rating is a 3 out of 5. And, well, look at that. Every single person gave it a 3. There is zero disagreement here. Everybody feels the exact same way about this product. It's fine. Perfectly, consistently, okay.
Now let's check out product B. Guess what? It also has an average rating of 3 out of 5. But the story could not be more different. You've got a bunch of people who hate it, they gave it a 1, and a bunch of people who absolutely love it, they gave it a 5. This is a classic love it or hate it product.
So I'll ask you, both have the exact same 3.0 average. Which one are you going to buy? Do you go with the predictable safety of product A, or do you take a chance on product B, where you might either love it or hate it? See, the average is useless here. We need something to measure this spread.
And that's where variance and standard deviation come into play. These are the statistics that finally give us a number to describe how spread out our data really is.
We have to start with this thing called variance. It's basically a measure of the total amount of spread. The way it works is, for every single data point, you see how far it is from the mean, you square that distance, and then you take the average of all those squared distances. It's a really important step. But the units are a little weird, right? Like square stars or square points.
So why on earth are we squaring things?
This quote from a Reddit user just explains it perfectly. When you square the distance, it does two things. It makes every number positive, but more importantly, it gives way more weight to the points that are really far from the mean. Outliers get amplified, which is exactly what we want when we're trying to measure how spread out things are.
And this brings us to the real star of the show, standard deviation. All it is the square root of the variance. And by taking that square root, we solve the square stars problem. We're back in the original units of our data. So now we have a number that tells us, on average, how far each point tends to be from the mean. A low standard deviation means consistency, just like product A. A high standard deviation means things are all over the place, just like our polarizing product B.
Okay, one last piece of the puzzle, and this one is super important. Most of the time, we can't survey every single person or test every single product. We have to take a smaller group, a sample, and use it to make an educated guess about the bigger group, the population.
So just to be clear, the population is the entire group we want to know about, every voter in the country, every single car that came off the assembly line. The sample is the small, manageable slice of that group that we actually measure. And the whole game is hoping that our sample gives us a reliable picture of the whole population.
And this is where a lot of people get tangled up. Standard deviation, the SD we just talked about, tells you how spread out the data is inside your sample. It's about the variety of ratings you collected. Standard error, or SE, is different. It tells you how much you can trust your sample's average. It's a measure of confidence. A small SE means you can be pretty sure that the average from your little sample is very close to the true average of the entire population. So there you have it. That single average number is just the first word in a much longer story. By looking at the center, the shape, and the spread, you get a way richer, way more honest picture of what the data is trying to tell you. So the next time you see an average presented like it's the final answer, you'll know to dig a little deeper and ask, okay, but what's the rest of the story?